Hello, Tiana.
Hi, ma'am.
How are you doing?
I'm like tired. But it's bad. Anyway, ma'am, I have a question, because I
Yes.
wasn't here last week, ma'am. But I just got up with a lesson now, like the lesson just ended now. So now, hello. Like my question is, the last one was talking about PE in the test, So now it is everyone in the class who took the PE test passed at least one section, 62% passes the theory section, and 63 passes the practical section. Now I'm asking, why is there intersection?
83, was it not 62 and 83?
Yes, ma'am. Now I'm asking, like, why is there intersection?
Because if there are 30 students in the class, it doesn't matter how many students are in the class, there can only be 100% of students. Yes, there can't be more than 100% of students. So if we've already got 62% and 83%, if we put that together, that's already bigger than 100% of the class, which obviously means that there's a particular percentage of kids who passed both. Are you understanding?
So whenever it's more in the full amount, more in the sample space, then it means it's an intersection.
Of course, absolutely. Let's look at this question here. I'm so glad you put your hand up because we're going to do that exact question to start off the lesson. Okay, look here. They're saying in a school of 320 students, right? 85 are in band, 200 are on the sports team, 60 participate in both activities. If we add up 260 and 85, how much does that give us?
It gives us 345.
How much? 345, right? So now this part is already bigger than our sample set. What does that tell us?
There's an intersection.
That is an intersection, correct. Okay. Is that making sense now?
Yes, ma'am.
Beautiful. Good stuff. Okay. Hi, Terika. Thank you. All right, guys, let's draw our Venn diagram of this information over here very quickly. Okay. I know that there's going to be an intersection, so okay, and then I'm going to draw another circle. There we go. All right, there's definitely an intersection, just as Tiana has said. Okay, we know that there is band and there is sport, and then there's going to be the overlap in between the two of them. Now, we know that 60 students are in both, right? But the full number for sports is 200, and the full number for band is 85. So if band is 85 and 60 students have already been accounted for, how much go to band only? How many kids do band only?
25.
I heard somebody say 25. Yes, absolutely. 25. We're going to go 85 minus 60, and that will give us 25. Right. And then if there's sports players and 200 of them play sports, but 60 of them have already been accounted for, how many of them play just sport without band? Correct, 140. Okay, 140. Now, I want us to be very careful because the question isn't completely done. Remember, guys, our sample space, our full sample, or let me say the universal sample, U, must be equal to 320. Now, if we look at how many we have inside here, guys, count them. 140 plus 60 plus 25, that gives us how much? 225. Correct. That gives us 225. But we've got a class full of how much? A class full of 320. So where did the other kids go? Tiana, what do we know about the other kids?
The other kids don't do any sports, so they like the
correct. They don't play sport. Correct. They're on the outside and they don't play sport or are in band, right? So how do we figure out that number?
So we say 320 minus
Mhm.
140 minus 60
Mhm.
minus 25, which gives us
Beautiful.
95.
95. Beautiful. Okay, good. So now we've completed the whole diagram. Does this make sense to you? Is it
Yes,
clicking?
ma'am. Yes,
Okay,
ma'am.
good. I'm glad. But now you have to answer some questions with me. All right. Now they're saying, how many students weren't in either sports or band? You've already answered for that for us. Right. That's 95. And then it says, how many students were in band or sports? What does that tell us? Is that the union or the intersection, guys? Band or sport? Union or intersection? Correct, Tiana. Beautiful. Good. It's the union. So it doesn't matter whether you do band or sport. We're going to count you in both, which means we're counting this or that. We're counting all of it. Okay, good. It's the union. How much is that altogether? It's 225, right? 225. Now, let's look at this next question here. It says, how many were in band but not sports? When we see that not, what do we call not when we're looking at our question here? What is not called in probability terms? What is not called? It starts with a C. We learned about it in the last lesson. The something. Yes, that's it, Asbonge. Beautiful. It's called the complement. So because we want not sport, but in band, right? We're going to take band union with not sport. Okay. Union with not sport. So we know that it's going to be band, but they shouldn't be taking sport. So only these students, these 25 students. 25. All right. All right. So we're going to be taking Venn diagrams today, and we're going to be putting it together with probability. Okay, we're going to put both of them together, and we're actually going to be looking at what to do with the information we've been given. All right, let's start with this question over here. They say, at Parktown Boys High, 110 learners were surveyed about their subject choices. The Venn diagram shows the results of the survey in terms of maths, physics, and accounting. Okay, so we know that our full sample space, N of our sample space, the number of people in our sample is 110. So all of these put together need to equal 110. First thing we're going to do is to make sure that all the numbers are doing 110. Miche, we're doing Venn diagrams. Okay, we're doing Venn diagrams, my sweetie. All right, because we're in the middle of probability. You came to us in lesson 3 of 6, so we've already started. Okay, we're doing probability and we're doing Venn diagrams. Okay. All right, peeps. So our first, yes, Mara, you can. Our first job, however, is to make sure that all of these numbers together actually give us the 110 that we're looking for. So everybody grab a calculator. Tell me, do all of these numbers add up, or do all of these learners add up to 110? Yes, Namisile.
No. Oh, good evening.
How many
Sorry.
do they add up?
I'm seeing 98. Now I got 93.
93. Okay, let's calculate. Okay, Funzo's also saying 93. So I'm inclined to believe it. Tatile, check your calculations again, my sweetie. Courtney is also saying 93. Okay. So, all right. So that means there are a couple of students missing, right? What does that tell us
Yes.
about the Namisile?
It tells us that there are a certain number of students that didn't choose or select these subjects.
Correct. Where do we put the number of students who don't do any of these?
Is it called the complementary? What? The square rectangle. It
Yes,
changes,
the
man.
rectangle.
Yeah.
Yeah. All right.
Yeah,
So we
which
know
is
that 80 students are here. How many students are left over?
17.
Correct. 17. Okay. So 17. So we know that the number over here is 17. Beautifully done, Namisile. Okay. That's it. That's all I needed to know from you. You did an excellent job. I always know. Every time I ask Namisile a question, I'm gonna get answers, y'all. Remember, guys, don't feel shy. You can put your hand up and ask a question or answer a question. It doesn't matter. Okay, it's perfectly fine. All right, good. Landile even called it the sample space. Now, let's talk about probability. Okay, remember, probability is going to be us taking the number of the event. So our probability of anything happening, the probability of an event is going to be the number of things in that event divided by the number of the sample space. Now, what we're going to be doing today, peeps, is we're going to be writing our answers as decimals. Okay, our answers are going to come out as decimals. Right, now here's what I mean. Before we get into the calculations, I know that in order for me to be able to calculate all 110 students, the probability of all of these things put together must equal 1. So what I mean by that is, let's think about the probability of, before we continue, let's think about the probability of flipping a coin, right? What is the probability that I would get heads, guys? The probability that I would get heads if I flipped a coin, what would that be? A half, correct. A half, or we're going to say 0.5, right? What is my probability of throwing tails? It's also going to be a half, correct? It's a half, or it's going to be 0.5. Now, when I take the probability of all the events that could happen in my sample space, if I take 0.5 plus 0.5, how much is that going to give me altogether? They add up to 1, correct. Okay, I'm glad Danvir is seeing it. Mika says, must the answer be on a second decimal? And should I round off? Yes. So if the question asked you to round off, it will give you it will tell you round off to 3 decimals or round off to 2 decimals. Okay. It will always ask us to round off. Right. Let's think about if we throw a dice. Guys, I know that the probability of getting 1 is 1/6. The probability of getting a 2 is also 1/6. The probability of getting a 3, 1/6. Probability of getting a 4 is also 1/6. Probability of getting a 5, 1/6. And the probability of getting a 6 is also 1/6. Now, what are we going to get if I add all of these probabilities up together? How much are they going to give me? Correct, Sandagate. They'll give us 6/6, which would then be 1. I would get, if I add up all of them, the probability of the total must be 6/6, which is equal to 1. So when I say that the probability of all events in this sample space, all of them put together must equal 1. Give me a thumbs up if what I'm saying makes sense. Okay, so if we calculate the probability of kids who take maths only, and we take the probability, or let's say the kids who take maths, plus the probability of the kids who take physics, plus the probability of the kids who take accounting, plus the probability of kids who don't take either, what should the full probability of all of these things equal to? Namisile, what should it equal to?
Oh, 1. Okay, that's
Beautiful.
not why I raised my hand, but that's okay.
But you gave me the answer anyway. All right, what's your question?
My question was, so for the events, when
Yes.
we using E probability when N over E divided by N is
Yes.
So I wanted to ask, for the events, do we include the learners, the group that didn't select the subjects, or do we just say 3 over what? 110? What? Yeah. Yeah, 110. Or do we say 4 over 110?
For which part? Where would the 3 and the 4 come from?
The 3 will come from the subjects chosen, for example, maths, physics, and accounting. So that's the 3. And then the 4,
The 4 would be the kids who don't do it at all.
including the kids that don't do it at all.
No. All right. Remember, Namisile, we're not actually counting how many events there are. We're counting the number of learners in each event. Okay, so we're never going to
each
one
event.
or two. Yes. So we're going to be counting how many learners take maths? Okay.
Oh,
Or how many
okay.
learners physics? Okay. Am I
Oh,
making
now it
sense?
makes sense. Yeah, thank you. I got confused there. Thank you.
No worries. Good question. That is a very good question. Tiana, what's up? Everybody who's just gone, who's in the chat, say hi to Teacher Simone because Teacher Kat has had to leave us. Say hi to Teacher Simone, everybody. She's our TA for today because Teacher Kat and Teacher Nelly are having technical problems. So say hi in the chat. Hi, Tiana, what's up?
Ma'am, so ma'am said 8, 7, 9, and 6, ne?
Mm-hmm.
Is that the people who do all 3 subjects together?
No. All 3 subjects would be this middle, this eye of the storm that we have over here. These students over here.
Only
Okay,
one.
I'm going to show you how it works. I'm going to show you how it works in the question in just a little bit. Okay.
Good.
I'm going to show you. All right, let's actually put all of this to the test and then we'll put it together. All right, now. All right, so remember, guys, we are calculating for the probability, and the probability must come over the number of the sample space. What is our NS, by the way? How much is NS? Tell me in the chat, peeps. Correct, Namisile, beautiful. NS, the number of elements in the sample space is 110, correct. Okay, so let's look at the first sum over here. They're saying, what is the probability that a learner chosen at random does none of the 3 subjects? How many kids do we have that take none of those subjects? 17, correct. So the probability of them doing none is going to be 17 over 110. That's it, Sandakasha, good Tanvir. That's it, excellent. 17, and now I'm writing 100 instead of 110. Sorry, 17 over 110. I want you guys to turn that into a decimal for me. Give it to me, correct, to 2 decimal places. Miche, you heard me? 2 decimals. Okay, 2 decimals. Namisile, do you have a question for me? I see your hand is still up.
No, I just wanted to answer because I think I'm getting the hang of this. So I wanted to have a participate. So yeah.
Okay, excellent. Okay, let's look at this next one because this one is going to be a little bit trickier. Okay, it says here, what is the probability that a learner chosen at random does only one of the 3 subjects? Okay, let's go look at our Venn diagram. How many students do only one of each?
Okay, for accounting is 20.
Correct. And
for physics is 22.
And then for
math it's 21.
Correct. Okay. So do you agree with me, Namisile, that when we are calculating for each of these probabilities, this is an or question, right?
Mm-hmm.
It's or. So we need to take this. You can either do accounting or maths or physics, correct?
Yes.
Correct. You can take either of them and you would apply. So when we write or, what we're going to do, Namisile, is we're going to add the probabilities. Okay, we're going to take the probabilities of maths or physics or accounting, and we're going to add them together. So let's start with the probability of accounting. How much is that going to be?
Ooh, okay, 20 over 110, which is equals to 0.18.
Okay, yeah, let's do them all together at the same time. 20 over 110 plus?
Plus 22 over 110.
Correct. Plus?
Plus 21 over 110.
Beautiful, good. Give me a final answer.
It is 0.57.
Okay, good. 0.57. Because if we add all of these numbers up together, we're going to get 63 over 110. And if we write it as a decimal, we're going to get 0.57. Beautifully done. Excellent. Would you like to try one more? And then I'm going to pick on someone else.
Yeah.
Okay. All right. Now, I want you to read the next question. Make sure you're understanding it completely. It says here, at least one of the three subjects. What does that tell us?
Ish, you see the English here. Uh, yeah, at least one, isn't it? Like, yo, one, yo, I don't know.
Okay, let's think about it. All you have to do is take at least one of the subjects, right?
So I can
At least-
pick any.
Correct. We can pick any. So the probability
Oh,
would probably be
okay, let me
maths,
use like,
the whole of maths, or the whole of physics, or the whole of accounting. All you have to do is do at least one of those subjects.
let's
Okay.
do maths because obviously in like a maths class, so like, yeah.
Okay. But remember,
So,
we're the probability. So we're not going to choose just one. We need to calculate the probability of all of them.
oh, okay,
Okay.
no problem.
Not
Okay,
just one. No worries up
okay,
here.
let's start off
How would
with maths.
you do it?
Okay, I would first add the learners. Nee,
Correct. We'd add them all
the
up. And we already kind of have. You've already given me the answer. How many learners were all together?
Sure, let me. It is 45.
No,
Oh,
all of them together. How much was it?
wasn't it 63?
Not 63.
All of what, ma'am?
All of the learners. You just said we must calculate all of the learners.
Oh, 110. No, it
Not going
is
to be 100. Only
93.
the learners
93.
who take maths,
93.
physics, 93, correct. So our
Yeah.
probability is going to 93 over how much?
110.
Correct, over 110. Okay.
Okay,
All right.
before we go, like,
Mhm.
anyway, can we like, so when you say at least one of the three subjects,
Mhm.
do we calculate all the subjects, or can I do one,
Yes.
then
Okay.
calculate
So
another
remember,
one,
yes,
or calculate another one?
correct. Okay, we don't have to do them separately. Even this one that I did before, we didn't have to do it separately. We could have done it all together. But Namisile, if I say to you, you only have to take at least one subject, does that mean you only have to take one subject?
No.
No, it means I can take one subject, or I can take two, or I can take three. Okay. Am I making sense?
Yeah, I was liking probability. The problem is the English.
I'm sorry, my sweetie. It is very important that we read it. Okay, correct. Okay, so it says here, at least one subject, which means I have to take one or more subjects. Now, if I pick one, just maths, that's one, but that's at least one. Or I can pick two subjects, or I can pick them all. Okay, I can pick all three of them. Is that making sense?
Yeah. Oh,
Okay.
okay. The answer would be 0.85.
0.5. Good. All right. 0. All right. I'm going to speak to Tiana very quickly because she's saying that she's a bit confused. Is that okay, Namisile?
No problem.
Excellent. Excellent. Tiana, where did I lose you?
Ma'am,
Yes.
the English lost me. It's lost me.
Okay.
How can you say at least? Then we put all of them together. So if we say it says at least one. So by at least
Yes.
two, what are we gonna do? We again gonna put all of them together.
Well, not for at least two. Okay, because if you think about it, let's look at it, Tiana. So if I take at least one subject, it doesn't matter which subject it is, right? But if I take at least two, I have to take two or more subjects, right? So that would mean the intersection. Because remember, if you are here, if you're part of the 7, which two subjects do you do if you are here with the 7 students? Which two subjects do you do?
Accounting and maths.
And maths. That's two subjects, right? Agreed? Are you with me? You sound a little bit skeptical. Okay. All right. What if I'm only counting these students over here? What subject do they do?
Maths.
Maths. Do they do any other subject?
Nope.
No, they don't, because they know there's no intersection, right? So what about these 8 students? What subject do they do?
That's in physics.
Correct. Do you see how you're counting two subjects? Yes. So when they say at least 2 subjects, that means 2 or more subjects. What that tells me is you can either do maths and physics, or you can do maths and accounting, or what else can you possibly do?
Physics and accounting.
Correct. Physics and accounting. Or what else can you possibly do?
All of them together.
All of them together. Correct. So that's what they mean when they say at least 2 subjects.
So all the intersections.
Correct. All the intersections.
So at least one means union. Ne?
Correct. It means union. Remember, we spoke about that. At least one means that and something else together with something else. Okay.
Ma'am, how am I gonna know this if I write the test? What if I forget?
The English must English. I don't know how to help you. The English, it must English. I'm very sorry, my sweetie. I'm only a maths teacher. I don't know how else to help.
This is so hard.
Okay, sorry, class monitor Jasmine. She says that we're being cringy. Okay. All right. Now, let's think about this next one that comes here, guys. Let's look at this question. It says to us, we need to count the probability. Sorry, we're not even done. Guys, please give me the probability of at least 2 of the 3 subjects. What is the probability here? Count all of these numbers up together. 8 plus 9 plus 7 plus 6. That's 13, 22. That must be 30. Am I correct? Do I have 30? I think I've got 30. 15, 22. Yes, good. So the probability of at least 2 subjects, at least 2, is going to be 30 over 110, which is equal to, remember, we are writing our answers as decimals. So give me decimals. Oh, Danveer, I'm going to hire you as my assistant because you're just out here answering all my questions. I love it.
I was gonna say, like, my job is done. I was not needed here.
You know what I mean? I just like sometimes, Teacher Simone, I feel like they can teach the class. Sometimes I'm just going to give them the class to teach and I'm going to take the night off, you know, because
Yeah, I think that's a good idea because you have a smart bunch with you today.
No, I mean, I'll still keep the money, but they can teach it. You know what I mean? Hi, Mara, what's up?
Ma'am.
Yes.
Wait, how do you get the 100? I'm confused.
It's not 100. It's supposed to be 110. Sorry, it was my fault. I'm sorry. I keep writing 100 instead of 110. Sorry, Mara. I didn't mean to write that. Okay.
Okay.
All right. Sorry.
Thank you.
It's my mistake, peeps. Okay, let's look at this next one. It says maths and accounting, but not physics. What do we call that not? Do we remember what we call not, guys? What does not mean? Not means the what? The what? We spoke about it in the last lesson. Funzo's like the what? Yes, the complement. Beautiful, the complement. All right. It's the complement. So let's go have a look, guys. They want the whole of maths and accounting. The whole of maths and accounting. Right. Maths and accounting, but not physics. Okay, so that means we can't include this part and this part and that part because those parts are part of physics. Okay, so when we say maths and accounting but not physics, we cannot include 8 or 9 or 6 because those make up part of physics. All right, so what would my probability then be? Correct. Zoom user, is that you, Offense? 48 over, let me write it properly, 110. Give it to me as a decimal, please. Thank you, Namisile. Hi, Offense. Correct, 0.44. Excellent. All right. Now I want to look at this next question over here. It says M union. Yes.
Sorry, before you move on, I wanted to ask, it says maths and accounting. So would we not only include the 7?
Oh, yes. Sorry, it's and not or. Thank you, teacher. Ooh, thanks, teacher Simone. Sorry, guys. I'm lying. Remember, union is or. Union is or, not and. And would only be the numbers that come up in maths and accounting. Ooh, thank you. Sorry, guys, before I teach you the wrong thing. Sorry. Maths and accounting would be this part over here. Yeah, guys. Sorry. Remember, union is or and intersection is and. So we're not looking at the union, we're looking at the intersection. Thank you, teacher Simone. This is why you're here. This is why we yes, thank you. We must look at the language. This is why we need teacher
Yeah,
Simone.
I feel like
here.
I did something, so I'm happy.
This is great. Thank you. Tiana, what's up?
Ma'am,
Yes.
but the nine, like they do physics.
Correct. We were about to get to that. The 9 can't be included because the 9 also does physics. So who are we actually counting here, Tiana?
The 7.
The 7, correct. See, you do get it. You are getting it. Yes, 100%. Sorry. So clearly, guys, I lied to you and the answer wasn't 0.44. The answer should have been 7 over 110. Thank you, teacher Simone and Tiana. You guys are doing the most. Thank you, Miche. Our answer here is 0.06. Okay. Whew. Thank you, teacher Simone. Thank you, Tiana. You guys are doing the most. Love it. All right, let's look at the next. Yes, true. Thank you, teacher, class monitor Jasmine. Have a look there. All right, let's look at maths union with not physics. Right, so the union, remember, union means everything, guys. Union would mean everything. So we're going to include maths and everything that is not physics. Okay, so if I look at maths, this would be maths, but I won't include everything that is not physics. So this is the one that I will choose over here. I'll do it again, Asbonge, in just a second, right? And then what is everything that is not physics? What else is left that's not physics, guys? Correct, accounting, but accounting only. We need to make sure, because if we include 6, that would also be part of physics. So we can't include the 6 because 6 is part of physics and we want nothing to do with the physics part of it. Right. What else did we miss? What else did we forget? Correct. And the 17. Yes, correct, Funzo, because the 17 is also not part of physics. So we need to include that as well. So 20, 21, 7, and the 17 as well. So we need to add all of them together over 110, please. So what is that? 48, 65. Oh, offense, very, very quick. 65 over 110. Please give it to me as a fraction, not a fraction, a decimal. Let's have it together as a decimal. Thank you. 0.59. Beautifully done, guys. Amazing stuff. Give me a thumbs up if you're understanding everything that's happened. Okay. In the meantime, Asbonge, let's go back to this question that says and. Right. Okay. When they say and, Asbonge, the condition is that you must do maths and you must do physics. You have to do both. You can't not do both. So if we go to the part where we do maths and accounting, maths and accounting is this part over here. It's this part over here. But the question also tells us that you have to do maths and accounting, but you're not to do physics. And these 9 students in here, they also do physics. So we can't include them. The only kids we can include are those kids. All right. Yes, Tiana. What's up, Tiana?
Ma'am,
Yes.
so why are we eating the 17? Because like they say maths union, not physics. So like the 17 is not doing maths.
Correct. It's not doing maths, but it's not doing physics either. Correct? Because all they want is anything that's not physics. They didn't specify that it has to be just the kids who are in the three subsets. They just said if you don't do physics. So everyone who does maths and everybody who doesn't do physics. Okay, so the 17 on the outside, they also don't do physics, so we must include them. Okay, am I making sense?
Yes, ma'am.
Okay, cool. Excellent. All right. Okay, it's like, let's think about this. Let's say, for instance, they want the students who do maths but don't do physics because the kids who only do maths have a test. Now, these kids can't stay in the room because they don't do maths. So why would they stay? They must go also. Okay, all right. Are we ready for another example? This time I haven't given you guys the Venn diagram. You need to put the Venn diagram together yourselves. Okay, let's read the information we've been given, peeps. Okay, it says here, a school organized a camp for their 103 grade 12 learners. Okay, the learners were asked to indicate their food preferences for the camp. They had to choose from chicken, vegetables, and fish. How many circles are we going to have, guys? How many circles? Correct, Namisile, beautiful. We're going to have 3 circles. Right, so there's our sample space. We're going to draw 3 circles. Another one, and another one. Okay, and let's do our research. Let's see. It says here, 2 learners do not eat chicken, fish, or vegetables. 5 learners only eat vegetables. 2 learners only eat chicken. 21 learners do not eat fish. 3 learners eat only fish. 66 learners eat chicken and fish. And 75 learners eat vegetable and fish. That was so much information, guys. Whew. Okay, let's go back. Let's go back. Okay, slowly. Let's go slowly through this information. Now, before we start, I need to remind you guys that the words that have been used are very important. Okay, I'm just going to move this circle a little bit. Let's move everything a little bit over. Okay, and take this one, move it up a little bit. I will. Okay. All right, so let's make sure that we're 100% understanding everything. So we've got chicken, we've got vegetables, we've got fish. And Namisile, I see you're dying to help. So of course you can raise your hand. Absolutely you can. All right, guys, remember, when it says 5 learners eat only vegetables, that means that they must sit inside the vegetable circle, but we cannot include them in between with the intersections. They cannot be included there. That only is very, very important. Okay. Then they say to us, 21 or 3 learners eat only fish. That means that goes in the only, in fish only. It cannot be part of the intersection. Only when they start saying things like 66 learners eat chicken and fish. And that and then starts telling us we're looking for the intersection. But before we even get started, count up how many students we have. Peeps, let's count up all the students together. Count them up. How much do we have? Let's see if we actually have 103 students. Namisile, you want to unmute? Let's have a conversation. Okay.
Yeah, I'm still counting.
How many students have they counted all together?
It is 174.
Yeah. So we're already off to a bad start because over here we have 103, right? So that 174 tells us that we definitely have many intersections somewhere. Are we in agreement?
Yes.
Okay, so let's start with the obvious. Let's start with number 1. Number 1 says 2 learners do not eat chicken, vegetable, or fish. Where does that go?
In the square.
Correct, in the square. None of those were included. Okay. All right. Now it says 5 learners eat only vegetables. Where do we put that?
In the V circle, but it shouldn't be included in the chicken or fish circle.
Beautiful. So 5 goes here. Right. And then it says 2 learners eat only chicken. So that goes,
Chicken circle.
yeah, intersection, correct. Okay, now this 21 learners do not eat fish. We're going to come back to it, okay, because it's a little bit complicated. Right, now it says 3 learners eat only fish. So where does that go?
The fish circle.
Correct, 3 learners go here. Now, I want you to note something. It says here, 66 learners eat fish and chicken. What does that tell us? Where does that go?
It should be in between the chicken and the fish.
Correct. It's the intersection between the two of them. Correct?
Yes.
But
Yes.
now, here's the problem that we're going to have. Do we know how many students eat all 3?
No.
No. So what are we going to name it if we don't know how many kids eat all 3?
X.
Correct, we're going to name it X. Now, here's the problem we're going to have. If we take the 66 learners that eat chicken and fish, does that mean they don't eat vegetables?
No, because it didn't say
No.
only.
Correct, it didn't say only. So what that tells us is if this is X, this isn't just 66. What is it going to be?
66 minus X. Yeah.
Correct, minus X, because we don't know how many students. Right. Okay, is that making sense?
Yes.
Okay, now it says 75 students eat vegetables and fish. So vegetables and fish will be
75 minus X.
correct.
In the-
75.
Yeah, that's circle ish.
Good. Good. Now let's go back to this statement. The statement says 21 learners do not eat fish. And if they don't eat fish, what does that tell us? What do they eat?
They eat chicken and vegetables.
Correct. They eat chicken and vegetables. So where does this 21 then go?
In between the chicken and vegetables.
Correct. Do we need to say 21 minus X?
No,
Why not?
because they stated that they only eat 2 of the provided food.
I'll give you whole hugs, just high fives all around. Beautiful. They don't eat fish, so we can't include them in the intersection for fish. So 21 right there. Beautifully done. I mean, wow. Excellent. All right.
It's me again.
Our job is to find X. Right. How is
Find
it?
X. Okay, ne. We write all the numbers equals to X. Ne. So 2 plus 21 plus 5 plus 3 plus 66 minus X plus 75 minus X.
I'm so sorry to interrupt. Teacher Coco,
Yes.
I have another question.
Yes.
I did probability a long time ago, but my question to you is, it said that 21 learners don't eat fish. So wouldn't the chicken
Oh.
only and vegetable
And
only?
vegetable only also fit. Ah, Teacher Simone, what would I do without you? Okay, we've made a tiny mistake. Namisile, we need to go back. Okay. And thanks for pointing that out again, teacher. Guys, like just Teacher Simone can take over. Okay, so what she's basically saying is if 21 students do not eat fish, but 7 of those students have already been accounted for. Okay, 7 of those students have already been accounted for. So this 21 that doesn't eat fish isn't going to be 21. It's going to be 21 minus vegetable and the chicken that we've already counted. Whew, and just so 14, correct. Thank you, teacher. Teacher Simone, this is why I need you in my life. I need you in my life. Thank you. Okay, so let's start this equation over again, Namisile. I'm so sorry, my sweetie. Let's start again. What would we get?
Okay. It's okay, 2 plus 14 plus 5 plus 3 plus 66 minus X plus 75 minus X.
Plus,
No, it's equals to
no,
x.
equals to how much? It
Oh,
can't
plus
equal
2, plus 2.
correct, plus 2 plus x. And all of it must equal our sample space. How much was our sample space again? How many learners?
103.
103. So all of these things together must equal 103. So I'm going to add plus x plus 2, and all of it must equal 103. Okay, am I making sense?
Yeah. So, okay,
Mhm.
we're gonna say, let's add the numbers first, like terms. So 2 plus 14 plus 5 plus 3 plus 66 plus 75 plus 2 is equals to 160. 67, not 65.
167. Okay, 167, right?
7. And then negative x minus plus negative x is equals to negative 2x plus x, which is negative x.
Correct. So now we've got 167 minus x equal to 103, right? Next move.
Yes. And then we transpose the
Correct.
167.
Good. Take 167 over, and then we'll end up with negative x is equal to
Negative x is equals to negative 64. And then we
negative
change
64. That
the
means that x
negatives
is
to be
equal to
positive.
correct.
64.
Look at you, Namisile. Beautifully done. Just amazing, amazing, amazing. Very well done. Sure.
And then we subtract and get it because we said 66 minus, then minus, then minus. So
Right. So we
in
can
the
just add
center,
all the numbers. We know that the middle is 64, and then this part over here will be
and then we're gonna say 66 minus 64 is 2, and then 75 minus 66 is 9.
I will not minus 66, minus 64.
Minus 64, it is 11.
11. Good. So let's add up all of these numbers that we've just put here and see if they actually do give us 103. Okay, so we're going to take 2 plus 14 plus 5 plus 2 plus 64 plus 11 plus 3 plus 2. Guys, give me a thumbs up in the chat if it all adds up to 103.
Yes, it does add up to 103.
And we would have missed it. Imagine we would have missed it by 7 if teacher Simone hadn't helped us with that tiny little bit.
And I was going to be confused, and then I'll be
Right?
like,
Even me, I can't lie. Even me, I was going to be like, hey man, what did we do? Hey. I love it. That's it from us this evening. Teacher Simone, if you could run the poll for us. You guys, Teacher Simone must come back more often. We love her. Right. Guys, I hope this wasn't too confusing. Can I let you guys in on a little secret? This particular question that we just did is actually from a grade 11 worksheet. It's a grade 11 worksheet. So if you guys are understanding what's happening here, I'm telling you guys, probability is nothing. It's nothing. Because if you guys can get this, then it is what it is, guys. It's 100% everywhere. Denver's like, no wonder I didn't understand for 5 seconds. Yes. But because you guys were so great at the other ones, I thought I should challenge you guys a little bit, which this I think kind of did, right? Okay, class monitor, I'm going to ask you to put your hand up to say goodbye to all our patrons. Tiana, what's up?
Ma'am?
Yes.
Yeah, now I'm confused though.
Okay, where did we lose?
Like, I can't remember, but I know after the 21, I was lost.
Okay. Remember what we always say. If they don't specify only, right? If they don't specify that these things are only, then we have to assume that the other thing also happens. Okay. So
Okay.
let's say, for instance, I say to you, do you have TikTok, right? And you say yes. So I know Tiana has TikTok on her phone. Does that mean you don't have Instagram on your phone?
No.
No, that's not what it means, right? Unless I say, who of you has TikTok only? Then I can't count you in these people because you also have Instagram on your phone. Are you understanding what I mean?
Yes,
So I'm
ma'am.
looking for people who only have TikTok, right? So when this thing says here, 21 learners do not eat fish, right? Does that mean that they don't eat chicken or vegetables?
No.
No, they do. And so we can't count them twice because we've already included the kids who take chicken, who eat chicken, and the kids who take vegetables. So if 21 of those learners don't eat fish, we still need to include the 2 kids who eat chicken and the 2 kids who eat vegetables. Okay, because it didn't say only. Am I making sense?
Yes, ma'am. So that 66 minus x. Why are we subtracting it by x?
Okay, because they're saying 66 learners eat chicken and fish. Does that mean that they don't eat all 3?
No.
No. So if we just write 66, it means we've already included them in here as well. So we can't count them twice. Okay.
Oh, okay.
That's why we minus, because we didn't know what the middle number was, we need to make sure that we don't count them 2 times. Okay, same with this one that says 75 learners eat vegetables and fish. Does that mean that they don't eat all 3? Does that mean that they also don't eat chicken? No.
No.
So we have to make sure we don't count them twice. Okay.